Welcome to Precalculus Concept 26C. Additional topics in trigonometry. We're going to learn how to convert equations from rectangular to polar and then vice versa from polar to rectangular. So we have three boxes to talk about, and here is box number one. Before we begin, we kind of want to know what a polar equation even is. So we're going to define it as an equation whose variables are r and theta. I have two examples for you in the box here. I have on the left-hand side, r is equal to 5 divided by cosine theta plus sine theta. This would be an example of a polar equation because it has an r and a theta. Same thing on the right-hand side, r is equal to 10 sine theta. This is a polar equation because it has an r and a theta. And this is what we're going to be working with. Okay, here is box number 2. It's an example, and I'm going to show you how to convert from rectangular to polar equations. So remember, rectangular equations have x's and y's, and polars only have r's and theta. So our goal is to end up with something with an r and a theta in it. Okay, let's begin with example A on the left-hand side here. It has x plus y is equal to 5. I first want to start off by showing you x plus y equals 5, the graph, and of course you should recognize that as being a line, nothing more than that. So what we're going to do is we're going to come up with an equation that is the polar representation of a line in the polar form. So here's what we know. We know that every x is worth an r cosine theta, and we know that every y is worth an r sine theta. So the first thing I can do is I can substitute r cosine theta for x, and I can substitute r sine theta for y, so I'd have this. R cosine theta plus r sine theta is now worth a 5. And what we want to do is we want to isolate an r. So notice that I can factor an r out of this whole entire equation, or sorry, the whole left side, and I would have cosine theta plus sine theta is now equal to 5. And if my goal is to isolate the r, I would be left with 5 divided by the quantity of cosine theta plus sine theta. And then I would be done. So if you were sneaky enough, you could have saw the answer. So if I turn this on, check it out, you'll notice that the line just goes blue, basically, because I turn this on and off, right? So I have an equivalent statement in the polar form. Now, if I also turn my graph into polar, you can see right there that this line is now represented as 5 over cosine theta plus sine theta, which is the exact same thing as our x plus y equals 5 in the rectangular. Kind of cool, and wanted to point that out to you. Let's do example B. It says x plus or x minus 1 squared plus y squared is equal to 1. So again, let's take a look at what this would look like in regular old graphing rectangular coordinates. This is a circle. The radius is worth 1 in this case, and it's centered at a 1, 0. So not really a big deal there. Okay, you can see the answer is r equals 2 cosine theta. So how do we get that? So back over here. Here is what I know. I know that every x, again, is worth an r cosine theta, and I know that every y is worth an r sine theta. Okay, so I am allowed to go make those substitutions right back in. So here's what I would have. I would have r cosine theta minus 1 quantity squared plus an r sine theta quantity squared is worth a 1. Hopefully that part makes sense to you. Okay, now I'm going to square this binomial on the left-hand side. So what I would get is r squared cosine squared theta. So that's the first thing squared. And then multiply the two things together and then double it. So that would be negative 2r cosine theta. I'm just doing algebra here. And then take the last thing and square it and be a plus 1. Okay? And then over here I would have an r squared. This would be a plus r squared sine squared theta, and then is still equal to 1. Okay, I wanted to move my screen over to keep track of a few things. So what I'm going to do now is I'm going to group the r cosine squared theta and the r squared sine squared together, and here's what I would get. I would get r squared cosine squared theta plus this one, r squared sine squared theta minus 2r cosine theta is equal to 1. Now, hopefully you realize you can factor out an r squared from this, and you would get r squared times a cosine squared theta plus a sine squared theta minus 2r cosine theta is equal to 1. Now, we know that cosine squared plus sine squared, of course, is equal to 1. So I'm going to move this up here, and this whole piece is going to go to 1. So I'm going to get r squared times 1, basically, minus 2r cosine theta is equal to 1. So don't need to write that 1 there. I can factor out an r, and that would leave me with an r minus 2 cosine theta is now equal to 1. I just realized that I forgot to carry this 1 all the way through and all the way through. So therefore, this is now going to be equal to 0. So I'm going to have r times an r minus 2 cosine theta is now equal to 0 because I had a 1 on the left and the right-hand side, and I forgot right here to carry it through. So hopefully you realize you get 0. Now we're at a really good point, because check it out. I can use the zero product property. Either r is going to equal 0, or r minus 2 cosine theta is going to equal 0. Well, r equals 0 just means that the radius is equal to 0, so nothing is happening over there. Or this tells me that r is equal to 2 cosine theta, and that's what we're looking for. So the big reveal here is that this equation is a circle with a radius of 1 centered at 1, 0, and this is that exact same picture, 2 cosine theta, in the polar form, and I'll show you an example of that in here. So if I graph this one, x minus 1 squared equals, or plus y squared equals 1, we get that one. And then if I take this away, and I turn this one on, and notice that if I could put this in the polar, I get the exact same picture. So this is what we're learning how to do, convert rectangular to polar equations, and I'll head back over to my notes. Okay, here's the last box. I'm kind of zoomed out to show you we're going to do these 4 problems. The first 2 are kind of easy, and then the last 2 take a little bit more thought. Now we're going the other direction. We're going from polar to rectangular. So let's zoom in and let's do part A together first, okay? So I have r is equal to a. So, r is equal to 5. So what I do know that is that for every r squared, I would get an x squared plus a y squared. So if I'm given that r is equal to 5, if I square both sides, I would have r squared is equal to now 25, because 5 squared is 25. And then I can say, well, r squared is just x squared plus y squared is equal to 25. And now I have changed my polar equation into a rectangular equation. Okay, here's example B. If I know that theta is equal to pi over 4, remember in the last video I told you that every tangent of theta is worth a y over x. So if I say then the tangent of theta must be equal to the tangent of pi over 4, so I'm basically multiplying by tangent on both sides, I would get that the tangent then of theta is equal to, what is the tangent of pi over 4? It's a value of 1. So now I know that every tangent of theta is worth a y over x, so I can make a substitution and say y over x is worth 1. This would imply that y is equal to x is the equation that we're looking for. So the polar equation of theta equals pi over 4 is equivalent to the rectangular equation y equals x. Okay, example C says r equals 3 cosine theta. So for us, we know the following. We know that r is going to be 3 times cosecant of theta is 1 over the sine of theta. So therefore, r is equal to 3 divided by the sine of theta. And then therefore, I can multiply both sides by sine theta and get r sine theta is equal to the number 3. And I know that every r sine theta is worth a y. So therefore, y is equal to 3. So that one wasn't too bad. Okay, and then part D. I know that r is equal to negative 6 times the cosine of theta. So what I would do then here in this case, since I can't get an r cosine theta by itself, I would multiply both sides by r. So I would get r squared is now worth negative 6r cosine theta. This puts me in a much better position because every r cosine theta is going to be worth an x, and every r squared is worth an x squared plus y squared is now equal to negative 6x. Moving this to the other side, I would get x squared plus 6x plus y squared is worth 0. And now I have converted a polar into a rectangular. We can take this a little further by completing the square and getting it into its more standard form, which I can show you how to do tomorrow.